Yeah, there are several. Sorry, this. There are several criteria when series like summation a n converges. Absolutely. So we'll look at one of them, which will be very useful in this context. So which is called Cauchy's root test. So you have a series summation a n from 1 to infinity, series of complex numbers. Now we want to look at the following. Actually, look at this limit, so as n tends to infinity, look at mod a n to the power 1 over n. So look at this number. Limit might not exist, but limits will always exist. So let's call this number as alpha. Let alpha be this number. Then if alpha less than 1, the series summation a n converges absolutely. Alright, we actually have absolute convergence, and of course for if alpha greater than 1, the series diverges. A series of mods mod a n diverges to infinity. So these two are important. For alpha equal to 1, we will not have information, but this is what we need. Okay. So now look at this in the context of the following series. So let's consider the following. Consider summation a n z to the power n. Z is fixed complex number. So z is a fixed complex number. You look at the series, this one. You start from 0. It doesn't matter whether you start from 0 or 1. Alright? Now you apply this one. So what we need to look at is, so look at, in this case, alpha will be lim sup mod a n z to the power n full to the power 1 over n in tends to infinity. Alright? So now this will be lim sup n tends to infinity mod a n mod z to the power mod z mod a n to the power n mod z. Alright? Now this one is actually the same as this one, right? This series of numbers. Alright? So if this is, let's call it beta, alpha is that one for the coefficient, so this will be alpha times mod z. Alright? So now if mod z Now what happens? See, beta here would comes as alpha mod z. Z is definitely fixed, but if you want to vary z at some each of the points in a domain or whatever in an open set, so what you need the following: if mod z is less than beta by alpha, see, then beta, what you want is the following. Oh well, so here, so not this one, what we need, alpha less than 1, right? So in this case what we need, so by Cauchy's root test, if beta is less than 1, the series summation an z to the power n from 0 to infinity converges absolutely. Alright, so now beta less than 1 implies alpha times mod z less than 1. This implies mod z less than 1 over alpha. And what was alpha? Where alpha is lim sup as n tends to infinity mod an power 1 over n, right? So what we have is, we look at a series of this form, summation n equal to 0 to infinity a n z to the power n. Z is a fixed complex number for the moment. Now if you want to apply root test to get whether this converges or not, or at least what we want to get is the what z can we take so that the series converges. So that implies this corresponding to alpha. Here you get beta, which is lim sup n tends to infinity a n z to the power n to the power 1 over n. That comes to as alpha times mod z, where alpha is this one, Now this implies if beta has to be less than 1, implies this has to be less than 1, which means mod z is less than 1 over alpha. So see here for this series, what you have, if alpha is this one, this is 0, this x-axis, this y-axis, in the geometric planar representation of the complex number, alpha should, z should vary inside this disk, where the radius is 1 over alpha. Alright? So that is, and you see, if again by root test, if mod z greater than 1 over alpha, which means alpha times mod z greater than 1, which means beta greater than 1, then the series diverge, series an z to the power n 0 to infinity diverges. Therefore, this 1 over alpha is the unique number such that the disk with centered at 0, radius 1 over alpha, at every point in the disk the series converges, and every point outside the disk it diverges. So here it converges, and here outside it diverges. So we should give this 1 over alpha a name. This is called the radius of convergence of this series here. Okay, so let me define that. Radius of convergence. Now you consider a general series, not of this form around 0, but so the radius, let me put the definition. The radius of convergence of a series of a power series summation an z minus 2 power n is the unique number r greater than equal to 0 such that the series 1 converges absolutely at every point of the set z in C such that mod z minus a less than r and diverges on